This is Functions Part 1 video, Identifying Functions. So we're just going to cover the very beginning of functions today. These should be the easiest questions on functions on the test. So how do you identify a function? Well, first I'm going to tell you the question that they're going to ask you, usually. They're either going to say, is this a function? Or, more likely, they're going to say, which one is a function? Or, which one isn't a function? And in those two cases, they'll probably give you 4 answers. They could give you 4 graphs. They could give you 4 tables. The ones I usually see are 2 graphs and 2 tables. So you have to be able to do both of what I'm about to show you today. So first we're going to cover graphs. This can be rough. It doesn't have to be perfect. We're not graphing points today. We're just talking about the lines on a graph. So you got your XY coordinate plane. They might give you something that looks like this. So how do you know if that's a function or not? There's something called a vertical line test. In case you've forgotten, vertical means up and down. So how do you do a vertical line test? You're going to have to do this with your eyes more than likely, but on paper you'll be able to do it with a pencil or a pen. So let's say we drew a vertical line right there. Now first off, you're ignoring the X and the Y line. Those don't matter, so don't count those. So how many times did I cross this curve right here? I crossed it 1 time. Let's say I drew that same vertical line over here. How many times did I cross over here? Once. No matter where I draw a vertical line on this curve, I'm only going to cross it 1 time. So that's the test. If you only cross once, the answer is yes, it's a function. So this is a function. Let's say they gave you a curve that looked like this. Looks very similar to that. It's just pointed in a different direction. Here's the problem. If you do a vertical line test over here, you're not going to hit anything. Remember, the X line doesn't matter. So this one doesn't really count for anything. But if you draw a vertical line test right there, you're going to cross here and you're going to cross here. So in your vertical line test, if you cross more than once, the answer is no. So this right here is a no. It can be more complicated than that. Let's say you had one that squiggled up and down multiple times. A lot of people's first impression is to say no just because it's complicated. Well, if you draw a vertical line there, you're only crossing once. Draw one here, you're only crossing once. Doesn't matter where you draw a vertical line, you only cross that line once. So this would actually be a yes. It is a function. Again, you can take the same sort of shape, change its position, and if I draw a vertical line test through there, I'm crossing 1, 2, 3, 4 times. So anything more than once is a no. It is not a function. Now, one easy hint is that linear equations or straight lines, we'll talk about those later. So there's your linear equation, are always functions except one. And I'll draw that one here in a minute. So this is a linear equation, which just means it's straight. So no matter where I draw this vertical line, I'm only going to cross one time. So this is a yes. This is the one linear equation that is not a function. And that's supposed to be a vertical line. If it's a vertical line and you do a vertical line test on it, what's going to happen? You're going to cross infinitely. So it can't be a function. So it's a no. Even though you can cross lines over here and not cross it any, the question is, can you cross it anywhere more than once? And you can. So I added a little bit of directions to this because it's difficult to find a worksheet. But we're going to talk about minimums and maximums while we're identifying whether this graph is a function. So number one, well, we just talked about it. It's a straight line. So no matter where I draw this vertical line, I'm only going to cross one time. So this is a yes. Now I'm going to pause for a minute. We're going to talk about minimums and maximums. So on a straight line, usually straight lines keep going. Now this hollow dot means something else. We're not going to go over that right now. So I'm actually going to fill that in. Imagine that it's a solid dot. Over here you have a square. We're just going to imagine that that's a solid dot too. So this is actually not a continuous line. It's just a line segment. So if they asked you what the minimum or the maximum was, and they usually only ask you one or the other, you're just going to see the lowest point. So the lowest point is right here. You're going to go over and look, number 4. So your minimum is just simply a 4. This is your highest point. You go over here, it tells you it's a 5. So your maximum is 5. Number 2, is this a function? Well, you can test it anywhere you want, and it only crosses one time. So that's a yes. What's the minimum and maximum? Here's your minimum. Tells you it's a -4. Here's your maximum, +4. We did one just like this in the notes. So no matter where you drew your straight line, your vertical line test, you'd only cross one time. So that's going to be a yes. What's the min and max? Well, here's the highest point no matter where you're at, and that's at a 1. That would be your maximum. Here's the lowest point no matter where you're at, that's at -1. So that's your minimum. I forgot to mention, minimums and maximum only do with the Y line. Okay, they only want to know the highest point and the lowest point. They don't care about left or right on the GED. So is this a function? Well, I can draw my vertical line anywhere I want over here, and then I'm crossing 2 times. So this is a no. What's your min and max? Minimum is -1. Maximum is 3. So pause your video and take time to identify whether or not these 4 questions are functions, and then identify the minimum and the maximum for all 4 questions. Okay, this one, draw a vertical line, test straight through there, cross it twice, so it's a no. Your minimum, -4. Your maximum, 1. No matter where you draw your vertical line here, you can only cross 1 time, so this is a yes. Maximum is 2. Minimum is -3. It's very small, so it's difficult, but no matter where you draw your vertical line, you can only cross it once, so that would be a yes. Your maximum is 1, your minimum is -1. I wrote those backwards, sorry. So this one obviously crosses over itself, so you don't even have to check. That's always going to be a no when it does that. You can draw a vertical line through here and cross it 3 times, I believe. So your minimum down here where the loop ends is -5. Your maximum is +2. Okay, state whether it's a function or not. If you want to go ahead and pause your video and work on these 3. Okay, you draw your vertical line through here, cross it twice, and remember, even though you can draw a vertical line over here and only cross this graph once, that doesn't matter. It's if you can cross it more than once anywhere, then it's a no. This one, no matter where you draw your straight line, you can only cross it once, so it is a yes. Oh, and I forgot. Let's do some minimums and maximums. So this dot ends at +3, and it goes down here to -3. So this one's minimum is -3, maximum is +3. This one's maximum is 12, and its minimum is, since it doesn't go below that x line, that x line is the origin, so the minimum is 0. It doesn't go into the negatives. Now, this one is obviously not a function, because no matter where you draw your vertical line, you can cross this one twice. If it's a closed shape, it's probably never going to be a function. I can't think of any closed shapes that come back on themselves that would be a function. So those are always going to be no. Now, something I didn't say earlier, but I should have. They're usually not going to ask you a minimum and maximum when it's not a function. They're usually going to give you a function. So I've been giving you mins and maximums on these even though they're not functions. Usually they'll give you a graph that looks just like this for minimum and maximum. Okay, if you want to pause your video and work these three on your own. Okay, this is a linear equation. It doesn't go straight up and down, so it's a yes. Maximum would be 1, minimum would be -7. Again, it's a closed shape, comes back on itself. It's always going to be a no. We won't talk about min and maximum anymore on those. Here, it's kind of strange, it's split up, but these do happen when you have nonlinear functions. So you can draw your vertical line over here, or you can draw it over here. It doesn't matter. You're crossing 2 times on both sides. So that one is a no. Now this is more like a GED question is going to be. And I'm sorry that this cuts off when I print it. I don't know if it'll cut off on your computer or not. So this one says, which of the following graph represents a function? Now, be very careful when reading these questions, because if I added one word in there, it would change the answer. If I added not a function. So make sure they're asking which one is a function or which one is not a function. So they'll either give you 4 pictures, one of them will be a function and 3 won't, or they'll give you 4 pictures, one of them won't be a function and the other 3 will be a function. So let's look at these. Well, I can tell right away if I draw a vertical line through here, I'm crossing once there, so that one's going to be a no. It's kind of difficult to see, but there's a vertical line. It goes horizontal to here, and then it goes vertical down. And we said any time you have a vertical line, it's automatically going to be a no. So you can tell this one, no matter where you draw your vertical line up and down, you're only going to cross one time. So this one is your answer. Now the other way to do functions is with a table. Input-output table. Now sometimes you'll have to fill these out, but when it asks which one is a function or which one is not a function, they will always be filled out for you. For example, let's say we had that, and they said, is this a function? Well, there's a super easy way to tell if an input-output chart is or is not a function. You look at the X line. The Y line does not matter whatsoever. If you look at the X line, you're looking for duplicates. Are any of these numbers repeating? No, they are not. If there are no duplicates, it is a yes. And I'm going to prove it to you by drawing a graph. If you forget this on the test, you have graph paper on the back of your dry erase board. You can always sketch this out, or you can just do a rough one on paper like I do. So let's say we forgot this and we're just graphing these points. Remember, this is your X point, this is your Y point. So 2, 3 would be 2 over 3 up. Notice I didn't write any numbers on here. Numbers don't matter. I'm just guessing where the numbers are. It does not have to be perfect. 4, 6 would be 4 over, 6 up. 8, 12 would be 8 over, 12 up. 10, 15, 12, 18, somewhere up there. And you can see that it sort of forms a straight line. It doesn't matter if it's perfectly straight or curved. What's important is that no matter where you draw your vertical line test, you're only crossing one time. So that's what makes it a yes. Let's say they gave you this. Well, look at your X line. Even though you've got +2 and +4, that doesn't match up with -2 and -4. The signs have to be the same. So even though you got 2 and 2, one's positive, one's negative, 4 is positive, 4 is negative, and 0. So you got no duplicates, so that should be easy. Yes, but I'm going to show it to you. So 2, 3 starts out the same as the other one. 4, 6. -2 goes this way, 3. -4, 6, and 0, 2. So you draw something like that. You saw earlier, no matter where you draw your vertical line, you're only going to cross one time. So that's what makes that a yes. So those match up. Something I forgot to say. Notice that we do have duplicates here and here, but they're in the Y line. You got a 3 there, a 3 there. You actually got another duplicate, 6 here and a 6 there. Remember, the Y line doesn't matter whatsoever. You can have as many or as few duplicates as you want in the Y line. The only line that matters is this X line. Okay, is this a function? Look at the X line. You'll see you have a 2 and a 2. So automatically I know it's not a function. But we also have another duplicate, 3 and 3. Doesn't matter how many duplicates you have, one duplicate makes it not a function. So no, because there are duplicates. No, that's a weird way to write it, because there are duplicates. So write that on a different line. So there are duplicates, so the answer is no. And I'm going to draw it and prove it to you. So 2, 5 would be up here, 3, 6 would be up there, 0, 1, 2, -5, 3, 6, -6. So what you've drawn here is a curve like that. And from earlier, you saw that this crosses twice, so it's a no. Now they might trick you, try to trick you. Don't get tricked, because this looks tricky. It looks like it's a trick question, but it's not. So notice there's the same number every time in the Y line. What did I tell you? The Y line doesn't matter whatsoever. It's the X line that matters. Are there duplicates in the X line? No. So what they've done here is they've drawn a horizontal line, because if you're at 1, you're going to be at 3. If you're at 3, you're still going to be at 3. If you're at 5, you're still going to be at 3. 7, 3, 9, 3. So when you connect those dots, you've drawn a horizontal line. And remember, horizontal lines are just linear equations. So no matter where you cross with your vertical line test, you're only crossing one time. It's only vertical lines that are not functions. Horizontal lines are functions. So that is yes, because this line doesn't matter. It's only that line that matters. And that is the end of the video.